We've been taking data from experiments and deciding if the treatment we're giving is actually making a difference. Now, in math, we call that being statistically significant. So, for example, we did some penny stacking or stacking in our class, and we were trying to decide if which hand you used made a difference. The book did a study where they took 27 kids in the class, so 27, and each kid got a chance to stack the chips with their dominant hand, and they stacked it with their non-dominant hand. Now, in your mind, you might be saying, oh, well, I bet the dominant hand did better. That's true, but when it comes to math, we can't just use our opinion. It has to be on statistics. So we're going to assume that even though we see the average number of chips for a dominant hand is 32.89 and the average number of non-dominant is 27.33, we have to let the data do the talking and follow the mathematical randomization process in order to prove if your dominant hand truly is statistically better. So, assuming that we don't really know which one is better, we're just going to use our data, we're going to find the difference of the means. So if we find our difference of the means, that means we subtract these two numbers. When I do that, I get 5.56. Now this number, it's important to interpret what that means. That means your dominant hand is stacking 5.5 chips more roughly than your non-dominant. Again, fight the urge to think that that's good enough to show it's always going to be true. Now we know 27 people is not enough just to prove it, so we come to a simulator. And this is part of the randomization process that you probably can't do on your own, but I'll always give you the data or allow you to run the process on a computer. I've ran it 100 times here, and in this line you can see that it is a little before 6. Believe it or not, that is the 5.56 marking we were talking about with your difference of the means. So when I ran the study 100 times by simulating it, roughly 5 times, someone got their dominant hand to stack even more than 5.5 chips better, which also supports maybe our bias claim. But we need to go back to the back here about negative 5.56. I'm going to try to draw a straight line up here. Okay, roughly. So if I went at negative 5.56, these are people who said, my non-dominant hand is stacking actually more than 5.5 chips better than my dominant. It's important to include the other data that is maybe going against our original hypothesis. Now you might be concerned that this negative 5.56 cuts through this bar graph. As long as you show what number you use, if you don't want to include any of it, because technically you don't know how many, maybe all of them were only 4 chips better, 4.5 chips better, we don't know. You can include a couple if you want, you don't have to, but just make sure you show your work. Since there was 13 under this number, I'm just going to say 2. That's just an estimate. Let's just say 2 on average said, hey, my non-dominant was better than 5.5 chips. So I'm going to take my outside studies who said they had even greater difference than I did and add them together. So I've got 5 on the right side where my dominant hand was better, plus the 3 that I know for sure, and I'm estimating the 2. Again, if you estimate nothing or if you estimate different, that's fine. Just show your work. And then we divide that by 100 because we ran 100 trials. Well, of course, that makes 10 over 100, and therefore that's 10%, meaning 10% of the time, my dominant or non-dominant hand actually had a better stacking over than 5.5 chips more than my other hand. This number is important. Our goal is 5%. If you have less than 5%, we can actually say the hand that you got to do better in your study is actually the hand that will always be better. But since 10% is higher than 5, it is not statistically significant. All right, so that means we cannot conclude that your dominant or your non-dominant hand is better. Again, we were probably going for dominant this time based on our data, so it is not true that our dominant hand will always be better.